problems on page 256. And we were doing 1 through 11, but we did number 3 yesterday in your notes. Oh, it's 255? Oh, yeah, it's 255. 255. I really was not on the ball yesterday. Okay, so let's start with number 1. For number 1, it says the radius R and the area A of a circle are related with the equation A equals pi r squared. Yep. Write an equation that relates dA dt to dr dt. Correct. So A prime equals 2 pi r prime. Yep. Number 2. So for number 2, it says the radius r and surface area S of a sphere are related by the equation S equals 4 pi r squared. Write an equation that relates ds dt to dr dt, which relates the derivative of S to the derivative of r. That's all it's saying. So we have S prime equals, bring our 2 down, 8 pi r prime. Number 4. Number 4, the power P of an electric circuit is related to the circuit's resistance and the current of the equation P equals R, yeah, is that what that says? Ri squared. All right. So for part A, it says, how is dP dt related to dr dt and di dt? So for part A and number 5, all it wants us to do, oh sorry, and number 4, I said the wrong number, is find the derivative, yes. Now, technically that is going to be what rule? We have 2 things multiplied together, so it's the power rule, exactly. So derivative of r, of course, is r prime. The derivative of I squared is 2i prime, right? So product rule, we get P prime equals r prime times I squared. And I'm actually going to write it that way so we can see it. Plus 2i prime times r, or 2ri prime. And let's do part B. Part B says how are dr dt related to di dt if P is constant. So for part B, we're going to say that P is constant. So if P is constant, I'm going to go back to here. I have P equals Ri squared. If P is constant, I need to move one of those to the other side to do my derivative. Which one? And it's, again, it starts by saying, how is dr dt? So we want to move r by itself. So I'm going to divide by I squared. And I'm going to get P equals, not P equals, sorry, R equals. I divide by I squared. I get P over I squared. Now I have to do the derivative. And if I do the derivative, P is a constant. We can do it a couple ways. We can either do the quotient rule, the way it is, having P constant, or we can move I squared to the top and say I to the negative 2. To the top. So we're going to say R equals P I to the negative 2. So my derivative would be R prime equals, bring my negative 2 down, negative 2 P I to the negative 3 I prime. All right, moving on to number 5. Number 5, it gives us the diagonal of a box is S equals the square root of x squared plus y squared plus z squared. And it says, how is dx dt related to dx dt, dy dt, and dz dt? So we're going to find the derivative. We can do it a couple different ways. First of all, we can do a u substitution as an option. I think that's the best option. So we're going to say that u equals x squared plus y squared plus z squared. So my du would be 2xx prime plus 2yy prime plus 2zz prime. Over here, we technically have s equals the square root of u, or u to the 1/2. So now let's do our derivative. S prime equals 1/2 u to the negative 1/2 du. So now we have to plug stuff back in and put the u to the negative 1/2 where? Down below, on the bottom. So S prime equals, on the bottom, we have 2 square roots. U is x squared plus y squared plus z squared. On the top, we have du, which is 2xy prime plus 2xx prime. I just said that totally wrong. Yes. Correct. Plus 2zz prime. Do you see something we could reduce? Yeah, we can take all of the 2's and reduce by all the 2's. Good. Keep going. Very good. I agree, David. Nice job. All right, so before we go on to number 6, tell me what kind of questions we have. Is there anything that isn't making sense yet, or we're totally good? Yeah, it's just saying the derivative of all of it, right? Yeah, it's just saying derivative, right? Okay, number 6. For number 6, it starts off as, if A and B are the lengths of two sides of a triangle, and theta is the measure of the included triangle, the area of the triangle is A equals 1/2 AB sine theta. How is dA dt related to dA dt, dB dt, and d theta dt? So what are we actually doing here? We're finding the derivative. I agree. All right, well, technically we're multiplying 3 things together here, aren't we? Right? We have 3 functions that we're multiplying together. Okay, so trying to find the easiest way to say what we got to do. When it said you're doing the derivative of A, you're doing the derivative of B, and you're doing the derivative of theta, does it say we're doing the derivative of sine? Okay. So I want to work with just this piece first. Let's talk about that, okay? 1/2 A, and this would be A prime, and that would be B prime, right? All right, so we're going to have A prime equals, just start with it again, ignoring that last little part for a second. I have 1/2 A prime times B plus I have B prime times 1/2 A. So 1/2 A B prime. We all agreed there? Okay. So now, since this, when we're talking about theta, the rest of it's already been included, and I know we haven't done any derivatives like this. This is simply going to be plus 1/2 AB sine theta, theta prime. Now, we haven't really talked about any like that, so I don't think I ever see another one that's like all three multiplied together either. But, yeah. Now, you can undistribute the 1/2 if you want, but, I mean, it all still works the same, right? Okay. Let's talk about number 7. For number 7, it says the voltage V, current I, resistance R of an electric current, like the one shown here, is related in the equation. V equals IR. Suppose that V is increasing at a rate of 1 volt per second. So I'm going to come over here and say if V is increasing at a rate, that is a rate, which means it's a derivative. So what that's really saying is that V prime equals that it's increasing at a rate of 1 volt per second. Okay? Actually, I'll put it that way too, volts per second. If we continue reading, it says, while I is decreasing at a rate of 1/3 amp per second. So that means I prime is decreasing, or negative 1/3 amp per second. Right? That's our given information. That's our original function. It says, let t denote the time in seconds. What is the value of dV dt? So we're going to do the whole thing. And then what is the value of di dt? So starting with the first one. All it wanted to know is this part right here for part A. So I didn't read ahead. It was my bad. Right? So when it said the derivative of V, that's what it's asking for. Then for part B, when it said what's the value, or the value of di dt, that's the derivative of I. So that's part B. Okay. Then for part C, it says write an equation that relates dr dt to dv dt to di dt. So we're going to take this equation right here. What rule are we going to have to use? The product rule. So this is just ai prime, right? And this is r prime. But we have v prime equals I prime times r plus r prime times I. So that's part C. Part D says find the rate at which r is changing. So we're going to be solving for r prime because that's a rate. When v equals 12, I equals 2, and then it wants to know is r increasing or decreasing. So we have v prime, we have I prime, we have v, and we have I. Let's plug all of that in and solve for r prime. V prime is 1 equals I prime, which is negative 1/3, times r put r here just a second. I think I said that wrong. And then r prime. All right, I got to back this up because I made a mistake. I apologize. Can we back it up for a second? I misread it for a second. All the information is still correct. This is my equation that's off. So let's go back to here. All right. It says relate dr to dt to dv to dt to di to dt. So since it started with dr, we need to solve for r first and get r by itself. Okay? So how do I get r by itself? Okay. So I have r equals I over v. No? How about v over I? Oh my goodness. It's one of those days. V over I. So what rule are we going to have to do here? The quotient rule. So we have r prime equals. Huh? And do the product rule? We can. Do you want to do it that way? Okay. So the derivative of the top is v prime times the bottom minus the derivative of the bottom times the top divided by the top squared. Or sorry, divided by the bottom squared. What is going on with me today? Divided by the bottom squared. Oh my goodness. All right, so let's plug everything in. We have r equals v prime is 1 times I, which is 2, minus I prime, which is negative 1/3, times v, which is 12, divided by I, which is 2, squared. So all I did was plug everything in they gave us, right? Okay, so I have here, this is 2. Negative 1/3, or negative times a negative is positive. 1/3 of 12 is 4, so this is going to be plus 4, divided by 4, or 2 plus 4 divided by 4. 3 over 2, I agree. I need to make sure we are right, yes. It is 3 over 2. So, since it is positive, is this increasing or decreasing? It is increasing because it is positive. Number 8. Number 8, it says, when a circular plate of metal is heated in an oven, its radius increases at a rate of 0.01 centimeters per second. So we have a rate for radius, so r prime equals, our rate equals 0.01 centimeters per second. Let's keep reading. It says, at what rate is the plate's area increasing when the radius is 50? So it also tells us r equals 50. The answer to this one is pi. You got it? Good. All right, so we're going to talk about area first. Area of a circle, A equals pi r squared. Our derivative of that is A prime equals 2 pi r prime. And now we're looking for A. So we're going to plug in r and r prime. So I have 2 pi times 50 times 0.01. So A prime equals 2 times 50 is 100 times 0.01 is 1. So 1 times pi is pi. All right, I want to kind of talk about the label a little bit because we haven't included the label yet, right? So first of all, they told us that our radius is in centimeters, right? So this is centimeters. So what we really have here is 2 times pi times centimeters times by centimeters over seconds. Yes, very good, David. It is. It's going to be centimeters squared per second. Yeah, Mr. Stern, close the door. All right. So by writing my labels like underneath, you can see what actually is happening in the problem to know what the label should be. That's the only reason I did that. All right. So before I go to 9, 10, and 11, is it clearing up a little bit? Are we? Yeah? So should I let you guys do 9, 10, and 11 on your own? You had a question on 9, so let's do 9 together. Okay, let's do 9, and then we'll do 10 and 11 on your own. Number 9. Number 9 says, changing dimensions in a rectangle. The length L of a rectangle is decreasing at a rate of 2 centimeters per second. So I know that L, if it's L prime, is decreasing, that's a negative. So negative 2 centimeters per second. Keep reading. It also says while the width is increasing at a rate of 2 centimeters, so my width, or W prime, is increasing at 2 centimeters per second. And then it tells you when L equals 12 and W equals 5, well, these are both centimeters, find the rates of change of first the area. So first we're going to do the area. Yep, so A equals, and technically area is length times width, right? Okay. So length times width means that A prime equals, we're going to do the product rule, so L prime times W plus W prime times L. So A prime equals, I have L prime is negative 2, W is 5, W prime is 2, and L is 12. So this is negative 10 plus 24. So 14. And what do you think the label is? Yeah, centimeters squared per second. So that's part A. Part B. The next one they wanted you to do was the perimeter. Perimeter. My equation for the perimeter would be 2L plus 2W. So my derivative of the perimeter would be 2L prime plus 2W. I take that back. It'd just be 2L prime plus 2W prime, right? Yeah. Because when we don't have an exponent there, that technically drops out. All right, so now let's plug in the stuff we know here. This is 2 times L prime, which is negative 2, plus 2 times W, which is squared. Yeah, let me make sure I did that right. It's wanting to know how much the perimeter is changing, right? Yeah, so P prime equals, it is not, the perimeter isn't changing, right? So it's changing at 0 centimeters per second. So think about what that actually is. It's saying as the length is going down, the width is getting bigger, and it's going at a constant, right? So they're changing at the same rate. So that's why it's 0. Okay? Third one. Now the third one's a little bit tougher. Part C wants us to do the diagonal of the rectangle. So I'm actually going to do a little sketch here to begin with. We are looking for the diagonal of the rectangle. If this is W and this is L. So then technically, I'm going to call that D. To find that hypotenuse of that diagonal, right, it would be W squared plus L squared equals D squared. Or in this case, we got to get D by itself because that's what we're looking for. Yeah, so D equals the square root of W squared plus L squared. So now the trick is to find the derivative of that, which means we have to do a what? Very good. We have to do a U substitution. Some of this out of my way. All right. We are going to say that U equals W squared plus L squared, which means my du is going to be 2W W prime plus 2L L prime. And of course, this is going to be D equals U to the 1/2. Move it up a little bit. All right, so d prime equals 1/2 u to the negative 1/2 du. So d prime equals, I have 2 square root of u, or the square root of w squared plus l squared. On the top, I have 1 times du, or 2w prime plus 2l prime. So what do you see we can cancel everywhere? The 2's. So I get rid of all of those. So I have d prime equals w prime plus l prime divided by the square root of w squared plus l squared. So now let's plug everything in. Our w value again was 5. Whoops, 5. Can we plug it in? Did I plug it in right? Yeah. Okay. Negative 14 over 13 on the bottom. So my diagonal is actually doing what in this case? It is decreasing. I agree. It is decreasing, and since it's a length, this is just centimeters per second. All right, so I'm going to have you guys do 10 and 11. You want me to get some of the information up there, so I'll do that for you guys to finish it up. Yeah, I obviously didn't download them yesterday, so that is my bad. So I'm going to have to just give you them this way. Oops. Here's number 10. I'll tell you number 10. Let's see, it says, suppose you have a box. The edge lengths are x, y, and z of a closed rectangular box, changing at the rates. So first of all, I'm going to go ahead and draw you your box. All right, so x, y, and z of my box. It tells you in the problem that x prime equals 1 meter per second. It says y prime is negative 2 meters per second. It says that z is 1 meter per second. Z prime is 1 meter per second. And then it asks you to find for part A, the volume. Then for B, they want you to find the surface area. And C, they want you to find the diagonal length. Which they tell you is the square root of x squared plus y squared plus z squared. And the additional information they give you on this is that x equals 4, y equals 3, and z equals 2. So you have 3 things to do for 10, and then I'll put number 11 here. Yep. For number 11, we have a spherical balloon. Spherical balloon. It's inflated at a rate of 100 pi cubic feet per minute. And then it says, for part A, how fast is the balloon radius increasing move it up just a little bit, and we'll move back down so we have some, maybe, there you go. Increasing when R equals 5 feet. And then for part B, he wants to know how fast is the surface area increasing at that instant. All right. Okay. So I'll give you guys those two questions to do. I'm going to pause this.